This video goes over some of the probability work covered in Stats 1. Okay, some definitions to start with. Where we've got the probability of an event, then that's the number of outcomes favourable to the event over the total number of possible outcomes. If you're not sure what that means, some examples might help. An unbiased coin, 2 possible outcomes, head or tail. So the probability of a head, that outcome is 1 out of 2, so it's a half. And the same for the probability of a tail. A fair 6-sided die. 6 possible outcomes, so the probability of odd numbers, of which there are 3, 1, 3 and 5, is 3 out of 6, 3 6, which can be simplified to a half. Here we have 5 red marbles, 3 green marbles and 2 black marbles. So the probability of picking out at random a marble and it being red is 5 out of 10, which again is a half. If an event's certain to happen, it has a probability of 1. So for instance, if we throw the same 6-sided die with integers 1 to 6 on each face, then the probability that our answer is an integer is 6 out of 6. It's 1. If an event's impossible, it has a probability of 0. So if we throw the same 6-sided die, the probability of getting a 0 is 0 out of 6, which is 0. So probability lies between 0 and 1. 0 being impossible, 1 being certain. If the probability is greater than a half, it implies the event is likely to happen, or more likely to happen. And when the probability is smaller than a half, it's unlikely to happen. Mutually exclusive events. If they can't happen together, they're mutually exclusive. For example, if we roll a die, event A is getting a 3, and event B is getting a 6. Event C is getting a multiple of 3. Which of these are mutually exclusive? Got it? Those two there, isn't it? So A and B are the only mutually exclusive events. 3 and 6 are both multiples of 3. So it's only getting a 3 or getting a 6 that are mutually exclusive. If 2 events are mutually exclusive, then the probability of getting one or the other is the probability of the first one plus the probability of the second one. So for example, if a card's drawn at random from a pack of 52 cards, then the probability of getting either a king or a queen is the probability of getting a king plus the probability of getting a queen. Well, there's 4 kings in the pack and 52 cards, so the probability of a king is 4 out of 52, and the probability of a queen is also 4 out of 52. So that gives us 8 out of 52, which simplifies to 2 out of 13. 2/13. Complementary events are where if one event happens, then there's an event that doesn't happen. So for example, if we say event E happens, then its complementary is that it doesn't happen. And in this instance, this is always the case. The probability of E happening plus the probability of E not happening is 1. So if you toss a coin, the probability of getting a head plus the probability of getting a tail are an example of two complementary events, because getting a head, if you get a tail, it means it's the same as not getting a head, isn't it? There's only 2 options. So probability of 1. Which of these do you think are complementary events? Well, the maths test is you can either pass or fail. That's all that can happen. But the rolling a die example, getting a 6, getting an odd number are not complementary. There's other options. And similarly, the card example isn't complementary. An independent event is where the occurrence of one doesn't affect the occurrence of another. So getting a head of a coin or getting a 1 of a die are independent events. If 2 events are independent, then we multiply their probabilities to find the probability of getting both of them. So this is a useful form of the equation we looked at earlier for complementary events. It enables us to find this if we're given this, and vice versa. So the probability that John will pass a test is 3/4, so the probability that he will not pass the test is 1 minus 3/4, a quarter. Looking at this question, 2 teams A and B play a soccer match. The probability that team A will win is 0.25 and the probability that team B will win is 0.3. These are mutually exclusive in the sense that there's no overlap between them. The probability that team A or team B will win the match is therefore the 2 probabilities added together. And the probability that the 2 teams tie, well, that's the complementary aspect, isn't it? Because either team A or team B will win, the only other outcome is a tie. 0.55 for that, and the 2 teams tying is 1 minus the answer to that, which is 0.45. So for 2 independent events, we multiply the probabilities, but if the events are dependent, before we multiply for the second event, we have to take into account a changed probability after the first event has happened. Looking at this example, if 2 cards are drawn one after the other at random from a pack of 52 cards, the probabilities all depend on whether we return the card to the pack. If we don't return the card from the pack, the second probability will be out of 51, won't it? But if we do return it to the pack, then the probability of drawing a king and then a club will be as they would from a pack of 52 cards. So the first bit first a king, well that's 4 out of 52, which is 1 out of 13. A club, Well, that's a quarter. So first a king and second a club, we simply multiply together and we get 1 out of 52. Probability of first the king of clubs is 1 out of 52, and then second the king of clubs is also 1 out of 52. So we multiply those together and we get 1 out of 2,704. Okay, have a go at this. If you can do this question reasonably comfortably, then you're very well prepared for the remainder of our work on probability. Okay, here's the answers. If you're not sure, go back over the video or have a look at the lessons on Moodle, or check this out on My Maths where it's covered extensively.